WonderForce.com.
Hello, I'm Hololina and Uliox my channel. In today's video will be a document about quantum paradoxes that might prove wildly held beliefs as false. Stay tuned and enjoy. Quantum physicists at Griffith University have unveiled a new paradox that says, when it comes to certain long-held beliefs about nature, something's gotta give. Quantum theory is practically perfect at predicting the behavior we observe when we perform experiments on tiny objects like atoms. But applying quantum theory at scales much larger than atoms, in particular to observers who make the measurements, raises difficult conceptual issues. Researchers have established the paradox by analyzing a scenario with well-separated entangled quantum particles combined with a quantum observer, a quantum system which can be manipulated and measured from the outside, but which can itself make measurements on a quantum particle. Based on the three fundamental assumptions, they have mathematically determined limits on what experimental results are possible in this scenario. But quantum theory, when applied to observers, predicts results which violate these limits. In fact, we have already performed a proof-of-principle experiment using entangled photons, particles of light, and they found a violation just as quantum theory predicted. But our observer had a very small brain, so to speak. It has just two memory states, which are realized as two different paths for a photon. That's why we call it a proof-of-principle experiment, not a conclusive demonstration that one of the three fundamental assumptions in our paradox must be wrong.
The paradox means that if quantum theory works to describe observers, scientists would have to give up one of three cherished assumptions about the world. First assumption is that when a measurement is made, the observed outcome is a real, single event in the world. This assumption rules out, for example, the idea that the universe can split, with different outcomes being observed in different parallel universes. The second assumption is that experimental settings can be freely chosen, allowing us to perform randomized trials. And the third assumption is that once such a free choice is made, its influence cannot spread out into the universe faster than light. Each of these fundamental assumptions seems entirely reasonable, and is widely believed. However, it is also widely believed that quantum experiments can be scaled up to larger systems, even to the level of observers. But we show that one of these widely held beliefs must be wrong. Giving up any one of them has far-reaching consequences for our understanding of the world.
For a more definitive implementation of the paradox, our dream experiment is one where the quantum observer is a human-level artificial intelligence program running on a massive quantum computer. That would be a pretty convincing test of whether quantum theory fails for observers, or whether one of the three fundamental assumptions is false. But that's probably decades away. That's the end of this video about the quantum paradox. I hope that it was informative and insightful for you. Thank you for visiting. Until next time.